In the previous video, we've refactored our product class, made it abstract, removed constants, one property, and added some of the methods which are required by this product contract. One method that we did not implement was this shipping. Now, because this product class is going to be a parent class of every type of the product class, we could obviously add this method directly within this parent product class. However, because we will extend this product for every type of the product, it makes sense as well for me to make sure that this abstract class implements this product contract. Rather than implementing this directly on each type, we can implement it automatically from within this abstract, and every single subclass of this product will have to make sure that it complies with the requirements of this contract. It will already comply with the ID method, price, weight, and is, but it will not have the shipping. Shipping will be the thing that needs to be implemented within each type, and that's going to be the only method that we will actually have to implement within each type. So let's quickly create the first type under the type directory and call it furniture. And it's going to be within the namespace app. Then we have product and then type. And it's a standard class which will extend product. And as you can see, my ID automatically highlights it. It tells me that class must be declared abstract or implement method shipping. If I was to remove this implement product contract, save it, come back, you can see this requirement is now gone because we're not implementing this contract here. So there are no requirements for this specific subclass. But because we have it, we need to make sure that the shipping is added to this furniture type. So we just quickly add this stub here. There we go. And let's add the implementation. So this shipping for the furniture, if we just go back to our order class, furniture shipping, I'm just going to copy what I've got inside of this method and paste it into the furniture. Now, shipping, let me just quickly explain one thing. If we go back to the contract, you'll see shipping doesn't have any arguments. And that's how we should implement this method, unless we provide arguments with the default values associated with them. So we can have a method declared within the contract, within our interface without any arguments, but we can still pass the arguments through to this method as long as they have default values associated. So for this specific shipping, we need quantity. So integer, quantity, and by default we have to define give it some value. It may be null, it may be anything. For quantity, it's an integer. I'm going to by default make it 1. So let's just add it to the doc block. Now for this product, we are already a product because we extend the product class, so we don't need to have a variable product. Now we just use this to refer to itself and then weight property on this product. And now this method represents the shipping approach for the furniture product type. Now we can save it and close it. Let's create another type. We had gadget, the next one, so gadget, and extend it and extend the product again, same way as we did before. Again, we need this shipping method. And let's go back to our order class for gadget. If we just copy all this back to our gadget class, let's paste it in. Now again, it's not a product that we need now, it's just this because we're referring to the property price on the product class which we are extending. And then quantity again, integer type, quantity by default 1. Look what's going to happen if I don't provide the default value. You can see it's automatically highlighting, telling me declaration must be compatible with product contract shipping method. And because the shipping method on the product contract doesn't have any arguments, we cannot have the argument that doesn't have any default value. But if we specify default value, then that's fine. So let's just add it to the doc block. And this class is also now completed. So we have price multiplying by quantity. If it's less than 50, then that's the price for the shipping. Otherwise, it's going to be free. Okay, save it, close it. And the last one was for the vehicle. So type vehicle. And let's just remove this unnecessary space again, and then extends product as well. And again, let's add this method shipping. For this one, we don't really need any argument. We simply return 0, 0 because that's what it costs to ship the vehicle, as we've discussed earlier. If we go back to the order class, you'll see the shipping is for vehicles is free, always free. Okay, so now our three different types are represented by its own classes. The next thing we need to do is to modify our order class to make sure that it works with these newly introduced changes. Now we're going to start with the add method. As you can see, this add method, the first argument that it takes, it's the instance of the product. Obviously, we could work this way, but this product abstract class now, obviously, doesn't guarantee anything. It implements product contract, but it doesn't say that this specific instance of the product class will have any of these methods that we have here. Now, in order for us to make sure that we have these methods available, we need to use the polymorphism. And the way the polymorphism works is that it allows us to specify what type of the classes we will be passing through as an argument. In this case, we can do it by using either abstract class, but our abstract product class does not guarantee that any subclasses will have a shipping method declared. We have, however, declared this product contract interface, and this is the interface that we actually going to type in here on this first argument. So if we use product contract, now we know that we can, and obviously let's update this dog block here as well. Now we know that whatever is going to be passed through as the first argument has methods such as, now here we obviously don't know about the property ID, but we know that this contract requires any class that implements this interface to have the method ID, which returns the ID of the given product. So this is where this polymorphism is going to allow us to inject any type of the product to this add method. So having this contract, we know that obviously whatever is passed through has ID. It also has the price method, has weight method, has shipping method, and has this is method. So we are now sure that when we passing the instance of this product contract, the instance of the class that implements this product contract, it will have all these methods available to us. Okay, so now add method is pretty much completed. Let's now scroll down. The has product needs to now use the method rather than property as well. So array key exists within the items array by this ID. Then for our remove method, exactly same situation. Rather than property ID, we are going to use the method, which returns the value associated with the property ID. And then for the shipping, well, shipping is going to be slightly different in a sense that we're not going to be modifying the shipping method as such, but we will modify the product shipping. And now look what's going to happen. We're still passing the array as an argument. We can rename it to, rather than item, just product, for instance, which makes a little more of a sense to me, and remove everything that we have within this method. Now I'm going to remove all of the following methods as well. So gadget shipping, furniture shipping, and vehicle shipping. We don't need any of this because if you think about this, instance of the product has already the shipping method within it. So all we need to do now is simply return then product, and we fetch the product by index product, and this is, if I just scroll up here, this becomes a little more obvious when we get here. Obviously we're adding these items as arrays, and to get the instance of the product we need to call this index product on this array. So that's why I'm calling this product, and then method shipping on it, passing item quantity, and that is going to, sorry, it's not item, it's actually product, we've renamed it quantity, and this is when we pass in the quantity to the shipping method. If I just open one of these types, furniture, for instance, this is where the quantity is being passed through as an argument to the shipping method. Obviously on vehicle is going to be ignored because we don't take any argument, but we can still pass it through. We just won't do anything with this argument. So now from within the product shipping, you can see how much cleaner it is, and it doesn't require any modifications if we add the new product type. It doesn't really care about what type it is, because it knows that by using this type hinting here, this product contract, we know that whatever product instance we are going to pass through, it will have this shipping method available, because this contract requires any class that implements it to have it. So we will be able to automatically call this shipping. It will calculate shipping based on quantity of this product within the order, and it will return it obviously back with this array map, and then it will summarize it and return it in a decimal format from within the shipping method. Now, another thing that we should probably do here is also change this type hinting for remove and has as well, because they also have to comply to the same contract. So product contract. Let's update the dog block, and the same for this has method. So rather than product, the abstract class, now we are type hinting this with the interface. Okay, so that's our order class also done. Let's now update our test and check if it's going to work. Okay, let's scroll up to the top. We have this correctly calculate shipping. First of all, we don't have these constants anymore, so we need to remove the second argument to this gadget. Obviously, we're not instantiating product because this is an abstract class now. We have specifically declared class, which is called gadget. So gadget, there we go. Let's import this class as well. And we can remove this product completely because we not go into this use statement here, because we no longer use it on its own. And then for furniture, we have furniture. Let's import this one as well. So it gets added here at the top. And again, let's remove this constant. We only have ID of the product, name, price, and weight. And the vehicle, it has vehicle type. And again, let's import it as well. Remove the constant. And everything else stays the same because we're still passing these instances to the order class, to the order instance, and then calculate shipping using a shipping method. So the only thing we've changed now is rather than instantiating new product, we instantiating specific type of the product and then passing them through as arguments to this add method. Okay, let's straight away do this second test as well. So rather than product is going to be gadget for this one, and remove this constant, and we comparing if it's a gadget. We keep the method name exactly the same because the method names, these are basically used dynamically, as you may remember, using this magic method call. So product is gadget, failed to identify is gadget. That still works. This should work the same way. And now for furniture, new furniture, and remove the constant. And the test is the assertion is going to be the same. For vehicle is the same. Vehicle, remove the constant, and the method call is the same. Okay, let's now save it. And if we open the terminal and run the test, and there we go, 2 tests and 4 assertions, all of which are still passing. So obviously everything, the functionality remains the same. We just refactored our code, so now it complies with this open-close principle. Now, before we actually wrap it up, let's also test the is method on each instance of this product, rather than having just this magic method testing obviously whether the product is of a given type. Let's now also add the assertion. So this assert true, and we're going to check gadget is, and let's pass string gadget. We know it's passing because obviously these magic methods are returning true, but I would like to have a strict assertions for this method in particular. So product is failed to identify gadget in this case, if this assertion was to fail. So if we save it, run the test again, and now 5 assertions, all of which are passing. I'm going to copy this assertion here, pass it paste it under this furniture as well. This time I'm comparing against the furniture and asserts it's furniture. Obviously it's not the gadget anymore. We're checking on the instance of the furniture, and the same for this vehicle one. So vehicle, and the name changes here as well, and obviously we are now testing it on the vehicle. Let's run the test again, and 7 assertions, all of which are passing, which is great. Now let's save this test. Let's save the furniture product contract as well. We can close the contract and we can close the order. Now I want to show you how easy now it is to add the new product type. So under the type, I'm going to add the new type and call it musical instrument. And this class will also extend product. So we need to add the shipping implementation. And for this specific product type, what I'm going to do is, first of all, I'm going to get a total. So equals this price property multiplied by quantity, which we need to pass through as an argument as well. So integer quantity by default 1. Let's add it to the dog block. So that's the total. Then we're going to get weight as well, equals this weight multiplied by quantity. And now I'm going to check if total is more than 500, let's make it, and weight is less than 100, then we are going to offer a free shipping. So return 0, 0, 0. Otherwise, the shipping is going to be 13, whatever, dollars, pounds, whatever currency you're using. So that's the shipping formula for the musical instruments. And what I need to do now, if we go back to our product test, I'm just going to test against this musical instrument now as well. So let's create a new instance. I'm going to call it instrument equals new musical instrument. Let's import it. And I'm going to give a product number 4, then say bass guitar. Then cost, let's make it 1200, 1250 for instance. And then the weight, what can bass guitar weight? Well, let's say, I don't know, 20 kilo. It's quite a heavy instrument. Okay, and now let's add this product. Let's remove all these comments here. We don't need them anymore. So after the last product, I'm going to add this instrument. I only want one of them. And if we run the test, and there we go, 2 tests, 7 assertions still, because we still are setting the same thing, obviously. But now that we've added the instrument, obviously, if we go back, total price quantity is 1, so price is 1200. So if total is more than 500, and it is, and then the weight, we said that this specific instrument is 20 kilos. If it's less than 100, then we offer this for free. But let's see what's going to happen when I'm going to increase the weight to 200. Now this test should fail. And there we go. Order does not return the correct shipping cost. Failed asserting that 2830 matches 1530. And that's correct, because that's exactly what we would expect. If it's under 100, so say 99 kilo, the bass guitar, and if we run the test again, that should return all green, which it does. If we go back, obviously, if you want to change it, so you can play with this as much as you want. Okay, and then obviously we can add another assertion here to the second test. So let's just create a new instrument. Instrument equals new musical instrument. And again, let's add 4. Let's make it bass guitar. Price was 1295, say, and then the weight, let's make it 50 kilos, and let's assert. Do you know what? Let's just copy this. Assert true for the instrument this time. It's not vehicle, is, and now musical instrument, because that's what the name of the class is. It's musical instrument, the name of the class. So is musical instrument, and for the message, product is musical instrument, failed to identify musical instrument, and product is for the musical instrument to identify musical instrument. Okay, I think all that's fine now. So let's give it a run as well. And there we go, 9 assertions with 2 tests, all of which are passing. So as you can see, it's so much easier now to add any new type, and we don't have to modify order class at all. Functionalities here, you can pass through any instance of the class that implements this contract. I don't care. I know it's going to have the methods that I need. So that's fine. So you just create a new type for the new product as many times as you want, making our component open for extension by adding new types, but closed for modification of any of the main classes.